Okay, so students, let's start EEEE problem solving session number 2. Let me adjust the screen. I hope the numerical is visible. Yes. So this is 2016 ESE paper, May 2016. So let's start with numerical number 1. We will be solving all the topics from module number 1. So we will be focusing on module number 1 questions. Module number 1, DC circuits. Alright, so let's start with the first question. So a resistor of 5 ohms is connected in series with a parallel combination of resistors each of 5 ohms. If the total combination is 6 ohms, find the number of resistors connected in parallel. Yeah, so let's start. So resistance of 5 ohms here is connected in series with a parallel combination of number of resistors each of 5 ohms. Alright, so there are a parallel combination of resistors. We don't know how many, so this can be any parallel combination of resistors are there. Now if the total resistance of the combination is 6 ohm, so they are saying the total resistance over here is 6 ohms here. So they are given the final value of resistance R, A, B. This is A, this is B. It is 6 ohms. Okay, so we have to find number of resistance connected in parallel. So this is 5 ohm, this is 6 ohms. So we need to find out how many such resistance are connected in parallel. Okay, so tell me how to solve this. How many such resistors should be connected in parallel? Any idea? So that the total resistance is 6 ohms. So how much should be the parallel combination value? Can you all tell me?
1.
Yeah, exactly. So this parallel combination value should be 1. Now please do 6 ohm parallel to 6 ohm. That will be 3 ohm, right? Correct? Then you connect another 6 ohm parallel to this 3 ohm. So how much is this? Can you tell me? 5 ohm is connected in series.
Resistors each of 5 ohms, right?
Acha, 5 ohm hai. Okay. I thought it is 6 ohm. So if it is 5 ohm, then it's okay. Okay, so this is 5 ohm, all are 5. So anyways, this should be 1 ohm, right? The parallel combination should be 1 ohm, correct? So 5 ohm parallel to 5, that will be 2.5. So again 2.5 parallel to 5, how much is this? Anyone? Hello? 2.5 parallel to 5, how much? Yeah, let me know the value.
1.666.
Okay, now 1.666 parallel to 5 again. Do this. 1.25, right? Yes or no?
Yes.
So now again 1.25 parallel to 5. How much? 1.25 parallel to 5. Yeah. So tell me how many resistance you should connect in parallel. This is 1, 2, 3, 4, 5, right? So 5 resistances, correct now, should be connected in parallel. So all the parallel resistance will be 1 ohm, such that the total resistance will be RAB will be 5 ohm plus 1 ohm, that is equal to 6 ohm. So 5 resistance should be connected in parallel. That is the answer to the first question. Got it? Everyone understood? Can we go on to the next one? Yeah, students? Okay. So let's go to the second question. So that cleared the concept of series and parallel resistance. Second question is, using mesh analysis, we need to find the current through 10 ohm resistance. So please draw this. So normally they won't ask for 3 marks, they will ask now for 5 or 10 marks. So this is normally a 5 marks question. So please draw the network along with me. This is 25 volt, this is 15 volt, 10 ohm, 15 ohm, and this is 5 ampere. We need to find current flowing through 10 ohm here, this. Okay, so we need to find I of 10 is equal to how much, and using only mesh analysis. Alright, so using mesh analysis we can start, right? So let's say current in the first loop is how much? We define it I1, and current in the second loop is I2. So is this an example of a super mesh? Yes or no?
No.
Yeah, no. Why? Because this 5 ampere current source is not set between these two loops. So can you tell me what is I2 directly?
5 minus 5.
No, not 5.
Minus 5. Minus 5.
Yes, minus 5, because the direction is opposite. Now we can apply mesh analysis in loop 1 and find out I1 easily, right? So write down KVL to loop number 1. So what do we get? This is minus plus, this is minus plus. Okay, tell me the equation. We are going from minus to plus, so plus 15, minus 15, I1 minus I2. Then we have minus 10, and here we are going from plus to minus, so minus 25. Oh, 10 I1, alright. So minus 10 I1 minus 25 is equal to 0. Now here we have to substitute the value of I2 also. So 15 minus 15 I1 plus, so here minus minus become plus 15 I2, correct? And what is the I2 value? Minus 5. Minus 10 I1 minus 25 is equal to 0. So we can combine the terms together. Here what do we get? 15 5 is 75, right? So 15 minus 75 minus 25 is equal to, we go that side, this will become 25 I1. How much is the value of I1? Tell me. Is it? Yeah?
Minus
3.5 to?
4.
Okay, 3.4 amperes. You all got the answer? Everyone? So direction of the current is like this. If we want to write the current positive, we can show the direction opposite. Everyone got 3.4? Okay, alright. So this was pretty simple. It was revision of your mesh analysis. Okay, let us go to the next one. This we completed within 5 minutes. Let us go to the third numerical. Are you all ready? You all completed? Okay. So we have your find node voltages. Node voltages are VA, VB, VC. So let's start. Let us draw the circuit together. This is numerical number 3. So we have to use nodal analysis, right? So let me draw the circuit. Please draw it along with me. 1 ampere. We have these resistances connected, and we have a battery over here. Okay. This is 2 ohm. This is 5 ohm, 4, 20, and there is one more branch which I forgot. So this should be 4 ohm, 10 ohm, and then we have a battery over here. Alright. Okay. So this is C, this is B, this is A. Now we have to find the node voltages VA, VB, VC. So the best technique is nodal analysis. Okay, let me know what we do in nodal analysis. We select the reference node first, then the 3 nodes are already there, so we call it VA, VB, VC. Is there a super node over here? Yes or no? Is there a super node over here?
No.
No, because for a super node, a voltage source should be connected between 2 nodes directly. Here it is not. Okay. Okay, by a smart observation, can you tell me what is VC? Voltage VC is how much?
5.
Yeah. 5 or minus 5? 5 or minus 5? Can you tell me?
-5.
Yeah, 9 minus 5. If you go from here, we have VC plus 5 is equal to 0. So VC will be equal to minus 5. That's correct. Because directly this voltage is coming between this node and the ground node. So we write this voltage as it is. Now one node voltage we already got. Other node voltage, how do we get? We apply KCL to the node A and node B. So let's do that. Let me mark the current. So this current is already coming inside 1 ampere. This is outgoing current I2. This will be I3, I4 and I5, because node voltage C we already got. So let's start. You write KCL at node A. So what do we get? What is incoming current? Incoming current is 1 equal to outgoing current is I2 and I3. So I2 plus I3. So now tell me, what is I2? It is VA upon 2, right? And what is I3? I3 VA minus VB upon 5. Alright, so you are getting these answers. So 1 upon 2 will be around 0.5 VA plus 0.2 VA, 1 upon 5 and minus 0.2 VB. So 0.7 VA minus 0.2 VB is equal to 1. Is it correct? Are you getting the same equation? Yeah, students?
Yes, sir.
Okay, yeah. So I just confirming whether you all are solving together. Okay. So now we apply KCL at node B. So what do we get KCL at node B? Incoming current is I3. Outgoing currents are I4 and I5. So I3 is VA minus VB upon 5. I4 is VB upon 20 and I phi is VB minus VC upon 4. Okay, and what is VC voltage? Minus phi. So we'll rewrite this. This will be um, this will be 0.2 VA minus 0.2 VB. What is 1 upon 20? How much it is?
0.05.
0.05 VB plus 1 upon 4 0.25 VB, and here it is minus or minus 5 upon 4. How much is 5 upon 4? Is it 1.25? Is it? Yes.
Yes.
Okay, so 0.2 VA minus, so club these all together, so we have minus 0.2 minus 0.05 and 0.25. How much it is coming? Half, right? Is this equation correct, everyone? Yes or no? Hello? By solving, is this what you are getting?
Sir, shouldn't it be minus 1.25?
Why minus?
VB minus VC, right?
VB minus VC, but VC is minus phi, na?
Okay, okay, got it.
Okay. So anyone else got these equations? So that we can solve this further. Can you confirm? Anyone else? Okay, so let's hope that they are correct. This is 0.7 minus 0.2, this is 1, 0.2 minus 0.5, 1.25. So please calculate VA and VB now in your calculators, and VC we already got. How much is the answer? VA is tell me in fraction form, that is fine. VA is how much?
25 by 31.
Yeah, and VB?
Minus 135 by 60.
Yeah, so that's correct. So VA voltage is 25 by 31 volt. Or does anyone else got it? Minus 135 by 62 volt, and VC voltage is minus 5. Correct? Yes or no? Anyone got this value correct?
Yes, sir.
Okay, now I'll teach you something which you will be learning and which will be using for your IA1 also. That is a tool called as LT Spice. So this tool will help you to simulate the circuit to verify the answers. Let me show you a demo. So let me quickly build this circuit together over here and find out the voltages VA, VB, VC. Alright. So let me connect the resistors here. Okay. So now let me connect the resistors here also. Don't worry, just give me a minute. I'll just show you how to connect this together. And there is one more over here. Okay. Okay, now I'll connect the power supply. So for power supply, I will go over here. Let me expand this a little. Yeah, here, and type current source. So here I'll rotate it, and I'll connect a voltage source like this. Yeah. So now let me connect this together as the circuit is looking over there. We are confirming the answer by the simulation tool, that's it. If the answers are, this simulation tool will give you the correct answers always if you made the circuit correctly. And I have to add a ground also, like this. Okay, and let me name this node as VA. This is A, this is B, and this is C. Okay, I have to connect it over here. So let me rename this as B, and this is C. Alright, this voltage is 1 ampere, this is 2, this is 5, this is 4. I think this resistance was not required, right? Yeah, so directly we'll connect a wire. This is 10 ohm, this is 20. Yeah, now let's simulate the circuit and find out the answers. It will give you VA, VB, VC directly. Oh sorry, I have to give the supply voltage also. Supply voltage is 5. So let me simulate, run. Yeah, so yeah, VA voltage, can you see VA voltage is 25 by 31. Can you do 25 by 31, anyone? Hello, can you do fraction 25 by 31? Is it 0.8064?
Yes, sir.
And what is 135 by 62? Is it minus 2.177?
Yes, sir.
And VC is minus 5. So you saw, if we simulate the circuit, we'll get the answers exactly matching with whatever we are doing in the theory. So this is another confirmation that whatever technique we are following is absolutely correct. Okay, this is verification by LT Spice tool. This I'll teach you separately. In fact, all the students of EEEE, that is all the P1 to P7 division students together, this will be helpful to solve your assignment number IA1 one question. Okay, so that's it about that. Now let us go back to our question paper. So far we have done series, parallel, mesh analysis, nodal analysis. Now next we go for source transformation. Are you ready, everyone? Yeah, so this is the question. Using source transformation technique, calculate the voltage across 4 ohm resistance. Okay, so let me draw the circuit. Let us try this. This is numerical number 4 for today. So let's draw this. Alright. This is 4 ohm, 10, 3 amperes, 2 ohm, 3 ohm, 6 ohm, and this is, they have written 6 ampere, but this is 6 volt. This is wrong over here. This should be 6 volt. Okay, so how do we proceed? Anyone? We have to use source transformation. So what I will change and what I cannot change. So basically this 4 ohm resistance I cannot touch, because ultimately we have to calculate the voltage across this 4 ohm resistance. Yeah, tell me. So can we start with this? These two will become what? A current source, right? With parallel resistance. So this value of this current source will be how much? Can you tell me? Anyone?
18.
No, how 18? Current is 6 volt divided by 3 ohm, so it's 2 amperes. Yeah, correct. This is 6 ohm, 2 ohm, 3 amperes. We draw the remaining circuit as it is, 4 ohm and 10 ohm. Now what do you see? What can we do? These two resistance are in,
Parallel.
yeah, So what's the parallel combination? How much it is? 6.
ohms.
So we have this scenario that current source is like this, and we have a 2 ohm resistance, 2 ampere. So what it gets converted into? A voltage source with a series resistance, correct? So what is the value of the voltage source? 2 ohm into 2 ampere, so that is 4 volt, right? With a series resistance. So let's draw that over here. We'll combine this entire circuit over here like this. Are you following?
Sir,
Yeah.
वो करंट नीचे क्यों जा रहा है?
Sorry.
करंट नीचे क्यों है?
That's how we define the current, right? Whenever there is a current source like this, let me show you. Whenever the voltage source is like this, right? Hello.
हाँ.
We have positive up and negative down. Okay, so the current will flow from positive to negative.
Okay.
Current source value. Got it?
Okay.
Or it should go from negative to positive. Anyone? What we have done earlier, just check. Is this correct, or we have done the opposite? Can you check any source transformation we have done before? Is the sign direction of the current source fine, or it is opposite? I guess it is opposite, right? Or is it this way only? Can someone tell me? This direction. Above only, na? It's from negative to positive or positive to negative? You can check your books and tell me. We have solved this before. Is it this way? Or it was the way earlier I have drawn? Come on, tell me, people. We have solved this before. I think second or third lecture we have done it. Not this. Let me just cross check the direction. Oh, this is source transformation. No. Yeah, this it must be. No, this is also nodal.
Sir, in the notes we have shown it upwards only.
Okay. We have shown upwards only, no? From negative to positive. You mean to say negative to positive, no?
Yes, sir.
Okay, we'll take it that way only. So it's from negative to positive. Yeah. I correct myself. It's negative to positive. Current source direction. All right. Now we.
negative से positive
Yes. Current source is negative to positive. So here we connect this 2 ohm resistance. Then we connect the next circuit. So these 2 ohms, these 2 resistance are gone. Now we have a series 2 ohm resistance. Okay. Again. And we'll connect the next circuit like this. This is 3 ampere, 10 ohm and 4 ohm. Okay. Now what do we do next? These two will be combined together, right? As how much? 4 ohm. 2 plus 2. Now this gets converted into a current source again. And the value of the current source is? Tell me now. 4 volt divided by 4 ohm. How much is that? 1 ampere. So we have a parallel resistance of 4 ohm. We got this circuit now. Are you following? Now we convert this current source and parallel resistance to a voltage source like this with a series resistance. Now tell me what's the value of this voltage source. Anyone? This is 1 amp.
वो 3 एम्पियर वाला क्या हो गया सब करंट सोर्स?
Where it is? Oh, sorry. I forgot that 3 ampere current source is there. This before, na?
Yes.
Yeah, it is before over here. And then we have these two resistances. Yeah, my bad. So that means you all are paying attention. Very good work. Now what you will do, instead of doing this,
So can we add the current sources?
we have to add the current sources only, because they are in parallel now, right? So what do we do is, this current source of 1 ampere we add it to this current source of, oh, I thought I did it together only. Okay, one step combined. So 1 ampere plus 3 ampere became 4 ampere. So what do I get now? 4 ampere, and then rest of the circuit follows. This is 10 ohm, sorry, this is ohm, this is 4 ohm, and this is 4 ampere. Now can we convert this current source and resistance? Yes? To a voltage source in series with a resistance. What is the value of this voltage source?
16.
Yes, it is 16 volt. This is 4 ohm, then we have 10 ohm, and this 4 ohm we want. Now can you see this circuit? Now in this circuit, can I calculate the current in this loop? I, what will be I? 16 divided by 4 plus 10 plus 4. How much is that? 16 divided by 18. So current is how much?
0.8888.
Acha, okay. No, but they are asking you to voltage across 4 ohm. So what is this voltage across 4 ohm? V4. This current into 4 ohm, right? So this is 16 upon 18 into 4 ohm. So how much is that? V4. 16 into 4 divided by 18. How much is that?
3.5.
Never ending 5, right?
एंड में 6 आता है बहुत बार.
Okay, not never ending 5. So we can write this much only. Okay, so that's the answer. Voltage across 4 ohm is 3.555. Everyone understood it? Yes, no? You have revised, your source transformation is revised now? Come on, tell me, I have to move ahead.
Yes, sir.
Okay, let me show you quickly how to do it over here. We can simulate any circuit and verify its answer in few minutes. So give me 1 minute, I'll do this and show it to you that the answer is coming almost same. So let me select current source over here like this. Then I have a voltage source somewhere around here. Then all these resistance are connected, one over here, one over here. Alright, now let me quickly connect this together. Oh, sorry. Alright, let me connect them together with a wire. I'll add the ground also. Okay, now this voltage is 6 volt, this resistance is 3 ohm, this is 6 ohm, this is 2, this is 3 amperes, this is 10, and this is how much? 4. We want V of 4, right? So I'm writing here V4. Let us check what is V4. Simulate, run, DC operating point. Okay, how much is V4? Can you check? Is it matching with the answer? Hello?
Yes, sir.
3.55. So this way I showed you, within a minute you can check any question ka answer using this simulation tool. Okay, so that's that. Now let's go to another circuit. Yeah, this is the one. So find the current through 30 ohm resistance using Thevenin's theorem. Let me yeah, one more is there, so 2 more numericals to go. Okay, one will be Thevenin's and other will be superposition. Maximum power and Norton's is similar, so I guess that is fine. Now we go for Thevenin's theorem. So remember, we have to solve it within 10 minutes time. So right now time is 12:15. So let's start. So we have to find I of 30 ohm using Thevenin's theorem. So let's start. This is 13 amperes, and this is 50 volt. 40 ohm, 50 volt, 30 volt, 30 ohm, 60 ohm, 15, 150, and this is ground. So can we start? So what do you do in Thevenin's theorem? First we calculate RTH, next we calculate VTH, and then we find the value of IL. In this case IL is I of 30 ohm. So what is my load, where is my load resistance? Over here, right? Yes or no? So this is A, this is B. So first let us start with RTH, A part. For RTH what we do? We deactivate all sources and we remove RL. This is a RL. So we remove RL and redraw the circuit with sources short circuited. So what will happen to voltage source? It will become short circuit. Current source will become open circuit. Then we have this resistance. This is removed. This is point A, and here we have a 50 volt, so this is point B, which is short circuited. Okay, so this is point B. Now tell me, what is V, what is RAB? We need to find RAB. How much is RAB? RAB is nothing but this B is here only. This is B only, right? As good as. Yes or no? So this is 15, this is 60, this is 40. Tell me what is RAB now. So I can simplify this circuit to this network. This is A, this is B, this is 40, 60, 15. Now tell me what is RAB. Come on. Is this 60 ohm and 15 ohm in series? Yes or no? Hello?
Yes, sir.
So we have 75 ohm. Now 75 ohm will be in parallel to 40. So RAB will be 75 parallel to 40. Calculate this, how much? it will be less than 40. Answer will be less than 40. 75 into 40 divided by 75 plus 40.
26.0869.
26.0869 ohms. Yeah, that's the answer. Okay. Next, what do? We need to find VAB. Okay. So VTH or VAB. So what do we do over here? Just remove the load RL and redraw the circuit. Okay, so I'm redrawing the circuit just by removing the load RL. Okay, this is A, this is B. This is 60, 13, 150, 15, 50, 40. Let me focus attention over here. Okay, this is the circuit. You have to find VAB. Alright? VAB over here. So let's say this is B, this is A. So here it will be VAB, right? If I check it over here, let's say this is VAB. VAB we have to find. So I mean, what to do over here? How to apply? We always start with B, right? And then we go to A. Yes or no? Like this. So we apply KVL to this loop. What do we get? So here we are going from positive to negative, and let's say this current over here is I2, this current over here is I1. So tell me, we are going in this direction. We are going from B to A, like this. So tell me, how will you apply KVL? You will get plus 50 or minus 50. You are starting from B and going down. Minus or plus?
Minus 50.
Minus 50, and then we are against the direction of current or in the direction of current? I2 is going this way and we are going up. Against the direction, right? Yes or no? So it will be plus or minus? Minus. In the direction is minus, na? Against the direction is plus, right? And here it is plus minus, so we are going from positive to negative, so minus VAB equal to 0. So how much is VAB? Minus 50 plus 40 I2. Yes or no? So that means we have to find I2 now. So I2 you can easily find in this loop, right? So is there a super mesh over here? Yes, there is a super mesh because of this 13 ampere current source. So 13 ampere forms a super mesh. So what is the equation of the super mesh? Can you tell me? I2 minus I1 or I1 minus I2? Yeah? I2 minus I1. Yeah, is equal to, yes, it's 13. Now we apply KVL to the super mesh. What is my super mesh? This is my super mesh. This one. This green color one. So let's start. We are going from negative to positive. So what it is? Plus 150. So we have to write, KVL to super mesh. What do we get? 150 minus 15 I1. Don't go over here, then go here. Minus 60 I2, correct? Minus 40 I2. Yes or no? Hello. 40 I2 equal to 0. So what do we get over here? Minus 15 I1 minus 100 I2 is equal to minus 150. Alright? Yes. So if everything is minus, we can multiply everywhere by -1, so we'll get all positive. Now solve 1 and 2 and get the answer. Are the equations correct? This is I1, I2. So here it will be -1, 1, 13. Here it will be 15, 100, 150. Now you need to tell me I1, I2. How much is I1, I2?
-10.
-10 and 3.
Okay, -10 ampere and 3 ampere. Now this we substitute in 1. So what is VAB or VTH equal to -50 plus 40 into 3, right? Yes or no? So how much is this? 120. How much is this? 70. So my 70 is the value of VTH. Are you following? Now what needs to be done? Draw Thevenin's equivalent circuit like this. Just draw it. VTH, RTH, and here I have my load RL. What is the value? This is 70. What is the value of RTH we got? 26.0869. 26.0869. And what is the value of RL? 30 ohm. We need to find the current through 30 ohm resistance. So this is 30 ohm. Can you find current through 30 ohm resistance? So I30. How much is I30 now? Can you tell me the... Yeah, V upon R, right? So it's 70 divided by 26.0869 plus 30. Can you calculate this? And let me know the answer. Amperes. Something 1 point
1.2480.
1.2480. Yeah, that's the... I don't know the answer, but we'll cross check it in 1 minute. 1.2480. Okay. So let me cross check this quickly. You can check. This is the way we have solved. And now we go back to the original numerical and try to replicate this over here in this tool. Okay, so we have a voltage source. Just 1 minute. It will take 1 minute only. We will have a current source. Direction is like this. Then we have all the resistances. This is 1, 2, 3. I'll directly find the current through the 30 ohm resistance here. So your simulation software is calculating directly the value of current through any resistor we can find actually. This is 150. It will hardly take a minute to solve. This is 13. This is 60. What I am doing, I am actually verifying the answer whether it is correct or no, right? This is 40. This is 50. Okay, let me add the ground also. Here is the ground. Yeah, let me simulate it. I want the current to be... Okay, what is I of V2 is in series, na? Hello, are you listening? I of V2, if I find the current through this voltage source, that means I found the current because these two are in series. So let us search for I of V2. How much it is? 1 point. Is this the answer we got? Correct now? 1.24806. So this is matching theoretically. That means all the whatever we have done so far is absolutely correct. The simulation software is confirming that. Okay, so if you do this patiently, then only you will get the numericals correct. Okay, so last numerical for the day. I hope everyone is following. Superposition theorem. Well, this will take around 10 minutes time. By the way, earlier numerical we took around 12 minutes. So let's wind up this. Last numerical for the day. I think numerical number 6. Here you have to be careful over here. Using superposition, we need to find voltage through 4 kilo ohm resistance. So everything is in kilo ohms and milliampere. We have to be careful in this. So let me draw this. This is 10 milliampere. Don't worry about the milliampere kilo ohms. Kilo ohms. Okay. Yeah. This is 3 kilo ohm. This is 25, 15, I of 1 kilo ohm, and this is 4. Okay, let me maximize this. Now we got the question. Okay, so what we cannot touch, this 4 kilo ohm we cannot touch. So what is superposition theorem? We have to solve this using, oh sorry, what do you mean by superposition? You consider one source at a time. So let's say you consider 10 milliampere current source, and you find a voltage across 4 kilo ohm resistance. Okay, so let's just call that V4 dash. Then you consider 25 volt voltage source, that we call it V4 double dash, and then we consider 15 volt and calculate voltage across 4 kilo ohm, calling it as voltage triple dash. So what is the superposition theorem saying? V4 is V4 dash plus V4 double dash plus V4 triple dash. So understood the theory? Can we start with this? So let's first consider 10 milliampere current source alone. First case. So I'll only draw 10 milliampere current source alone. Rest of the sources will be short circuited. Okay. So this voltage source, I will be drawing it as short circuit. Okay, this is short circuit, this is short circuit, this is 3 kilo ohm and 1 kilo ohm. Yeah, tell me, what will I find, or how will I find it further? Hello? Yeah, what is the voltage across 4K? I mean, how do we proceed ahead? Since, as you can see, this is a short, okay, and parallel to a short we have connected 3 kilo ohm. So we have a situation over here. We have a short circuit and we have a parallel resistance. So what it become? What is the result? A short only.
0.
Yeah, 0 means short only. So basically this gets transformed into 10 milliampere, and then we have this 1 kilo ohm directly connected over here, right? As it is, ऐसे बन गया ये, this way. Yes, but we cannot touch 4 kilo ohm. How will you proceed forward? We want voltage across 4 kilo ohm. So we want V4 dash. How do we proceed? Since all of them are connected in parallel, can I rearrange the circuit like this? 10 milliampere. Here we have 1 kilo ohm, correct? And then I connect this. Is this, can we do this? Yes or no? Yes, it's allowed because they are in parallel. Now these two will be converted by source transformation into a voltage source with a series resistance. Okay, So draw this. Let me close the document and open again. Yeah, there was some problem with it, so I've opened it again. Okay, so now what do we do? What is the value of the voltage source? Can you tell me? 10 milliampere into 1 kilo. Can you tell me how much is that? This is 1 kilo only. Hello.
10 amperes.
अरे voltage है. It's a voltage. So 10 volt ना?
हाँ हाँ वही 10 volts 10 volts.
What is this current? Can you find the current I1? I1 is 10 volt divided by 1k plus 4k. So how much it is? Is it 2 milliampere? Just check. Yes or no?
Yes, sir.
And now we don't require this. We want voltage V4. So what is V4, anyone? This current I1, V4 dash actually. This current I1 into 4 kilo ohm resistance. Yes or no? So V4 dash will be 2 milliampere into 4 kilo ohm. How much is that? 8 volt. Just cross check.
Yes.
Yeah. So we got one answer. Now we have to repeat the same thing for the other part. So please note it down. Now we'll go for another one, another case. Second, we'll consider 25 volt source alone. That means this current source and this voltage source will be deactivated. So what do we have? So we have this 10 milliampere current source open circuit. So this is open circuit. Then we have this 4 kilo ohm resistance. This is like this. Okay, this is 25 volt, this is 1 kilo ohm, and this is 3 kilo ohm. Now how do we solve this? Anyone? Come on, tell me. It's very simple. Do we apply any analysis over here, or we can directly find this? Yeah, how do we proceed? Tell me. I'm waiting for your answer. We want voltage across this V4 double dash. Yeah, how do we do this? Come on. Simple mesh analysis will help. We can find the current over here and find the current over here. Yes, can we do that? Or it is not necessary? Hello, any ideas? Or source transformation you want? Should we apply source transformation or any other technique?
Source transformation.
Okay, so here we have a current source with a parallel resistance. But what do we achieve over here by source transformation? We are complementing again.
आई मिलेगा ना उससे, तो फिर आई तो निकाल लेगी.
Where, which I? Not helping the case. Okay. If we see carefully, these two are connected in parallel. So can we interchange their position? No or yes? Yes or no?
Yes, sir.
Hmm. Or your normal mesh analysis will also do, no? It's okay if you don't do this also. Normal mesh analysis you apply. This is I2, this is I3. So tell me. और सबसे best will be nodal analysis also we can apply. So अगर nodal analysis apply करते हो तो here we have A, this is B, second point. हाँ. So now this current will be this current and this current. So tell me what is VB directly.
25.
Yeah, so apply KC VA we have to find, right? So how will you apply VA KCL at node A? So what it is? Outgoing current. So VA upon 4K plus VA minus VB upon 1K is equal to 0. Okay. So VB is 25. So VA upon 4K plus VA upon 1K, this is minus 25. Minus 25 upon 1 kilo ohm. Okay. So everywhere we divide by 1000. So what do we get? Divide by 1000. What do we get? VA upon 4 plus VA upon 1 minus 25 is equal to 0. Correct? Yes or no? So here we multiply and divide by 4, right? Let's say. So how much do we get? 5 VA by 4 is equal to 25. So what is VA? 25 into 4 by 5. This is 5, 20. Is it not? Hello?
Yes, sir.
So VA is 20, that means V4 double bar is 20 volt. Second answer. I hope you are following. Completed? I'll keep it here. See what we have done. Without using calculator, we can solve this answer. Okay. So we'll go for the third case, last case for the day.
सर वो आपने किलो ओम्स को कन्वर्ट नहीं किया?
किया ना मैंने. I divided by 1000. Oh, multiplied by 1000. Sorry, divide नहीं, multiplied. कैसे बताएं? This is 4000, right? 4K. So if we multiplied by 1000 throughout, this kilo will disappear, ना? तो ये 4 बच जाएगा. Correct or no? नहीं समझा आपको? हाँ. So that's how. Sorry, divide नहीं, multiply by 1000. So this will be 1000 A divided by 4000, 1000 VA divided by 1000 minus 25,000 divided by 1000. So that's how we got this. From this step to this step, you have understood?
Yes, sir.
Now we go for the third case. Let me show that as a reference. Third case is 15 volt voltage source. We consider 15 volt source alone. So what do you mean? This will be open circuit. Then we have 4 kilo ohm resistance, 1 kilo ohm. This will be short circuited. Okay. Now tell me, how will you solve this further? 15 volt, 1k. We cannot touch this. We need to find the voltage across this. Plus minus V4 triple dash. So what is V4 triple dash? I say V4 triple dash, the answer is 0. How? Tell me how it is 0.
वो शॉर्ट सर्किट हो गया इसलिए.
Absolutely. This has become a short circuit. So whatever is connected in parallel to the short will be a short only. So this circuit got reduced to this network. Okay. This is 4 kilo ohm. This is 1 kilo ohm. There is no current flowing because there is no source at all. So VAB, this V4 triple dash will be 0 volt. Did you got it? Yes or no? Everyone understood? So next we write, by superposition theorem, what do we get? V4 is V4 dash plus V4 double dash plus V4 triple dash. And how much is that? V4 dash is 8, 20. 8 plus 20 plus 0, which is 28 volt. So V4 is 28 volt by superposition theorem. Okay. Can we quickly simulate in LT Spice and show it to you? This is okay? Understood? Yes or no? Everyone followed?
सर ये 10 मार्क्स के लिए आएगा ना?
हाँ, if it comes, superposition normally comes for 10 marks unless it is very simple numerical. So this is, let me connect it quickly. Okay, over here and one is over here. Yeah, that is it. It will take me a minute to check the answer. Just wait. I want voltage across 4 kilo ohm resistance. This is 10 milli. This will be 4 kilo ohm. This is 1 kilo ohm. This is 25 volt. This is 15. This is 3 kilo ohm. Okay, let me mark this point as V4 or 4. V of 4 we will get then. Okay, ground is missing. Let me call that V4 only. Okay, this will directly give me the answer, right? How much is V4? Just check. Is it matching? Yes or no?
Yes sir.
So our answer, our analysis is absolutely correct. No problem with it. So this is the way we can solve any numerical calmly and patiently. You have to just go for your instincts and do it very calmly. Again, we took it around 12 minutes to solve this and we are like little overboard of time. So that's it for today. We have touched every concept, whatever is there in module number 1. Last time also we took one session wherein we have covered all the aspects of module number 1. Alright.